We use sum and difference identities when we are able to break down an angle into two angles that add to our angle or that subtract to our angle. All right. So in the last chapter, we learned how to evaluate trig functions of all of the angles on the unit circle. All right. And now we're going to use that here. With the sum and difference identities, we're now going to be able to evaluate the exact values of other angles. Okay, so for example, 15 degrees, 75 degrees. These are not on the unit circle, but now we're going to be able to evaluate those angles. Okay? All right, so here are the identities, the sum and difference identities. So what you have here is this. So you have sine of, these letters are the Greek letters for A and B, alpha and beta, okay, like in the Hebrew alphabet, they're all alphabet, right? It's all the same root. So it's sine of alpha plus beta. Now when you have plus minus like this, and here you have plus minus, that means you can have two versions, and this is just a concise way of writing two different formulas. So one version of the formula is sine of alpha plus, so we're taking the upper one, sine of alpha plus beta is the same as sine alpha cosine beta plus cosine alpha sine beta. So if it was sine alpha minus beta, then it would be sine cosine minus cosine and then sine. With a cosine, if it's cosine alpha plus beta, then you have cosine cosine minus sine sine. Okay? And if you have cosine of alpha minus beta, then this is a plus. Okay? Tangent is another one. So you have tangent alpha plus tangent beta. 1 minus tangent alpha tangent beta. So remember, for the tangent, it keeps the sign here. It switches the sign here. Okay? All right.
Why does it say plus minus if it's actually minus?
Huh?
Why does it say plus minus?
Because you could also have tangent of alpha minus beta, in which case it would be minus here and plus there. Okay? Yes. You have plus, plus, minus here, and then minus, minus, plus. So the top two are the same, the bottom one will switch. Now, there's a song. There is a song. If you write your sine, the sine and cosine in this order, right? So you see how for the sine of A plus B, it's sine A cosine B, cosine A sine B, but this is cosine, cosine, sine, sine, right? So here the sine and cosine alternate, here they don't. So if you write it in this order, all right, here's the song. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. And then you just sing it, and that's what it is. You just can't sing it on the quiz. Not out loud, huh?
Wait, you could say that song with any of the values and it would sound normal.
Right. But it doesn't. Right. But that would be the wrong lyrics. Okay, my kids sing it. My children sing it at home. They just don't know. They sing it at home. They just don't know where one word ends and where the other one begins. So it's like they're like sine, cosine, cosine, co. You know, like they'll end it in the wrong place. Okay. Shh, I need to hear the question.
Can't sine A plus minus B or alpha or whatever? Can it also be sine, cosine, sine, cosine?
Right, but then the thing is, we keep A and B in the same order. Like, you see? So then it would be sine B cosine A, and then you're just switching everything around. Okay? All right. So, how to use these identities? Here we go. Rewrite, so first you want to rewrite the angle as a sum or difference of angles found on the unit circle.
45 and 30.
Right, so the ones on the unit circle are, 0, 30, 60, 45, 90, and then, you have the other ones too. So you have like 210 and 135 and 120, and all of those are fair game. And if you can write it in terms of those, then you're good to go, okay? So for example, you could take 135 and a 30, right? Together, that's 165, and you can find like the cosine of a 165, okay? All right, so what if you have a radian angle? So what if you have pi over 12? I find that students have a little bit more difficulty with that. So for example, if you have pi over 12, now you need to find two angles on the unit circle that add to pi over 12. Here's how to break it down. So for a radian angle, rewrite the angles as two separate fractions with the same denominator. And then find numerators that add or subtract to the numerator and which will reduce to a special angle. It's just, it seems more complicated than it is. Finally, we apply the corresponding sum and difference identity. Okay, so let's take a look at this first one. I have sine of 15. I want to write it in terms of two angles that are on the unit circle.
Sine 45 minus.
Right, so it'll be sine of 45 minus 30. Okay, you can't repeat the sign. Let me actually write it to the left so I have more room. So this will be sine of 45 minus 30. So now this is the sine, right? So it's going to be sine, cosine, cosine, sine. All right, so it's sine of the first, cosine of the second, minus or plus? Minus sine, cosine, cosine, sine, right? Okay.
Could you have done 60 and 45?
You could have. Right? So, and you have to make sure that the order of the angle stays the same, otherwise none of it works. Okay, so now, this is why we learned all of that. Sine of 45 we know is root 2 over 2. So here it is. This is why I need you to be quick. Okay? You just need to know that sine of 45 is root 2 over 2. You need to know that cosine of 30 is what? Root 3 over 2 minus root 2 over 2 and 1/2. That's how much time you should spend on that step. And that's why I was pressing you in the last chapter. Okay? So now, this is root 6 on top, 4 on the bottom, minus root 2 on top, 4 on the bottom. And now we combine the numerators into root 6 minus root 2 over 4. Okay? And that's all you can do with this. You cannot simplify this any further. And that's the most simplified form. That's how your answer will look. Okay? Here, I'm missing the parenthesis.
Why can't we simplify that?
It just doesn't. Yeah. Yes. You would get the same answer. It's magic. Okay? So now, cosine of negative 15. Well, let's do that. You said, what did you say? 30, 60 and 45. Okay, so let's do that. Let's write this as cosine of 45 minus 60. Okay? Huh?
30 minus 45.
Right. You could do that too. You could do whichever combination. So now this is going to be cosine 45, cosine 60, plus.
Why is it 4?
Because for the cosine, the sign will switch. Right? If you look up there, if it's cosine of plus, then in the middle it's minus. Okay? So now this is going to be sine of 45, sine of 60. So cosine of 45 is root 2 over 2. Cosine 60, somebody at 1/2. Plus sine of 45 is root 2 over 2. Sine of 60 is root 3 over 2. And we already know cosine 60 and sine 60, right? If you use the 1/2 here, then it's the root 3 over 2 over there, right? So this is going to be root 2 over 2, root 2 over 4 plus root 6 over 4, root 2 plus root 6 over 4. You could say root 6 plus root 2 over 4. Okay, sine of 75, what are we going to make it? Sine of whatever what?
45 plus 30.
Sine of 45 plus 30, that sounds good. Yeah. No, it doesn't matter. You could do, if there's a different combination that you want to use, you could do that. If you want to do 30 plus 45, you could do that. Okay, so it's sine, cosine, cosine, sine, and the plus will stay constant. Remember, one way you can remember it is if the trig functions alternate, like you have sine and cosine versus sine sine or cosine cosine, if these alternate, then the sine, like the plus, will stay constant. Okay? Whereas if the trig functions are the same, then the plus and minus will alternate. Okay? All right, so let's finish this one. We have root 2 over 2, root 3 over 2, root 2 over 2, 1/2. This is root 6 plus root 2 all over 4. Okay? Huh? You see a pattern. I see a pattern. What are we going to write 105 as? 135 minus 30. You could totally do that. You could do 45 plus 60. Right? Which one do you guys want to do? Okay, 45 and 60. Okay. I'm going to race you to it. I'll stop the recording too for a second and okay, it's root 2 minus root 6 over 4. If you have root 6 minus root 2, there is a negative mistake somewhere. Okay? All right, remember it's sine, cosine, cosine, sine, and then it's cosine, cosine, sine, sine, right? So it's got to be cosine, cosine, sine, sine. Okay, now with this one. So what I want to do, so let me just work here. 11 pi over 12. Remember what I said to do here? Rewrite the angles as two separate fractions with the same denominator as the original. So here, two fractions with the same denominator as the original. Now, I want to put numerators here that add or subtract to the original numerator and which will reduce to a special angle. So for example, what are two ways I can get 11? One way I can get 11 is 1 and 10. But if I do, so it's 1 pi and 10 pi. But if I do 1 pi and 10 pi, does 1 over 12 and 10 over 12 reduce to an angle on the unit circle? No. So I want to find the combination here. 5 and 6 will work. No, they won't work. Why would 5 and 6 not work? Because 5 over 12 is not a thing. Huh? 3 and 8? Let's see. 3 pi and 8 pi will give you what? Pi over 4 and 2 pi over 3. Okay? So this will be pi over 3 plus 2 pi over 3. Do you see how? Oh, pi over 4, sorry. Are we okay with this? So now it'll be sine pi over 4 cosine 2 pi over 3 plus cosine pi over 4 sine 2 pi over 3. So sine of pi over 4 is root 2 over 2. Cosine of 2 pi over 3 is what?
Zero.
Negative a half. Pi over 3 is the bigger angle. It faces root 3 over 2. The cosine is 1/2, but cosine is negative at 2 pi over 3. Plus cosine pi over 4. And sine of 2 pi over 3 is going to be root 3 over 2, but positive this time. So remember, cosine 2 pi over 3, sine 2 pi over 3. I use the 1/2 here, then the root 3 over 2 is going to be over there. And I'm going to get negative root 2 plus root 6 over 4. And just a heads up, we usually write the negative term last. So like that. Okay? All right. I'm going to stop the recording for a minute. You're on your own for part F. So we're now we now came to the conclusion that for these you're going to get basically different permutations of the same values. And now, okay, this is like mind-blowing stuff. Okay, in the last section we learned about identities. Okay, we learned these identities. We learned that sine of pi over 2 minus theta was cosine of theta, and I just said, okay, it just is. Okay, but now we're gonna ask ourselves, is it really? And if so, how is that equal to that? Okay, so if this was in the radian form, we wrote it in degree form as sine of 90 minus theta is equal to cosine of theta, right? So let's just see, how did that come to be? How did that come to be? So let's see, where is it? Right here. So here I have sine of 90 minus theta, and I want to ask myself, is that really equal to cosine of theta? Is it really equal to cosine of theta? So you know what I'm going to do is I'm just going to work on the left side of this equation. Okay? What I have here is sine of alpha minus beta. So let's just put it in the formula. It'll be sine cosine minus cosine sine. Is that right? Sine, cosine, cosine, sine. Yes? So now, what's sine of 90? 1. So that's 1 times cosine of theta minus, what's cosine of 90? 0. What does that equal to then? Cosine of theta. So do you see that? Do you see how sine of 90 minus theta is just equal to cosine of theta? What's sine of 90? 1 times cosine of theta. What's cosine of 90? 0 times sine of theta. What's 0 times anything? 0. Let's do that other one then. So here we have cosine of 90 plus theta. Is that really equal to negative sine of theta? Let's just see. So here I have cosine minus sine sine. Okay? What's cosine of 90 these days? 0. All right. What's sine of 90 then? 1. Okay, so 0 times cosine is 0. So I have negative sine of theta. Yup, negative sine of theta. Okay? All right, so go ahead and do the other one. Go ahead and do the other one. You know the answers to these, right? Now, on the quiz, I might just say, find cosine of 90 minus theta. Okay, not verify that it equals to this, and you would just have to find it. I might just say, instead of verifying, I might just say find the cosine of 90 plus theta, and then you have to come up with the negative sign on your own. See what I mean?
Negative sine 0, negative sine
Like,
theta.
I won't give you this. I'll just say find that.
Negative sine theta equals negative sine theta.
Well, like from here. Because remember I was working on one side. I'm just verifying that yes, I did get what I was supposed to get. Okay, here. Cosine, cosine, plus sine, sine. Does it? What's cosine of 360? 1 cosine of theta plus what sine of 360? 0. So we get cosine of theta. Okay? All right.